And I believe that's a very important understanding, especially for those in positions of Christian leadership, that we're very much involved in spiritual war. Okay, so this is a slide that I've used in the past, probably for the last 10 years, talking about some of these strongholds that exist today. I think if I were to redo the slide, I might revise it some. But certainly these are areas where there's great deception going on in the world around us. And I put the centermost castle as uniformitarian geology, it's probably the key fortress here, but it's strongly, it's connected to all these other ones, so I want to ask the question: which stronghold around us is the most strategic at this point in history, the most strategic to seek to pull down? And I'm persuaded that it is the stronghold of deep time. Pull down that stronghold, and Darwinian evolution and uniformitarian geology collapse immediately. And so that was the point. That was the point of our rate project that several speakers prior to me have alluded to. That's because the primary support undergirding the dogma of deep time today is radioisotope dating of rocks. And this, how important this was grasped very keenly by one of the board members of the Institute for Creation Research in the early and mid-1990s. And he persuaded ICR to undertake this project. They were not all that excited about it, but his influence got this project that came to be known as RATE launched. So I was invited to join. We started in 1997. Larry Vardaman was the one that was sort of the initiator and the administrator and fundraiser and cheerleader for the project, and there were 7 of us scientists that began the project, including Larry, including Gene Chafin here, and myself, Russ Humphreys, Steve Austin, and Don DeYoung. And so we had 2 physicists, 2 geologists, Andrew Snelling. Okay, 3 geologists. Anyway, well, he was not an official. He was a strong part of our team, but he wasn't designated. They were mainly because he didn't have a PhD. He wasn't really official part of the 7 initially, at least. Anyway, the outcome of the project is that we identified multiple independent lines of evidence that revealed precisely why radioisotope dating methods so consistently yield ages for most of the Earth's rocks in the range of millions to billions of years. And the reason that is the case is that we identified is the false assumption that nuclear decay rates have been constant throughout Earth history. That assumption, which seems so obvious and so unchallengeable by most physicists, by most scientists, turns out we showed to be not correct. So we showed that there had to be episodes of very rapid nuclear decay in the past, since the Earth was created, that ran up lots of time, billions of years of time, on these radioisotope clocks. when in fact the Earth is only a few thousand years old, consistent with what God's Word says. And I'm going to summarize. I'm going to just briefly describe two of the lines of evidence that brought us to that conclusion. One rate project involved looking at zircons, tiny crystals that are found in granitic rocks that had retained most of their helium that had been produced by radioactive decay. And these zircons we studied were from a drill hole that was about 2.5 miles deep in the crust just west of Los Alamos in northern New Mexico. And this photo shows the drill rig. The hole was drilled in the 1970s as part of a geothermal research project, and various individuals had analyzed these the various aspects of the rocks brought up in this core. Our result, just to try to move this forward quickly, was the startling result that the measured rate of helium diffusion in these tiny zircon crystals was high, so rapid that the helium in those crystals could not have been there more than about 6,000 years. So there was 1.5 billion years worth of helium from uranium decay locked up in these crystals. We measured how fast it leaks out, and these measurements matched this prediction that we'd made 4 years earlier, that for a 6,000 year age it would require this diffusion rate. The measurements we got back from the best lab in the world for doing these kind of measurements fell right on that curve. The curve was from the measured levels of helium in the zircons at different temperatures from different depths in the core. So when we got these results, we could hardly believe it, that the fit was so perfect to the 6,000 year curve. And so this was one line of evidence that there had been that a large amount of nuclear decay had taken place in the recent past of the Earth. And I'll have a little more to say about exactly when in Earth history, relative to the biblical picture of Earth history, that this took place. It had to, since the uranium lead date for these crystals was 1.5 billion years ago. Basically, that age includes much of all of the pre-flood time, reaching back into Creation Week, and he also included the time since the flood. So I'll say a little more about that in a moment. Okay, so that was one project and one spectacular line of evidence that nuclear decay rates have been dramatically different in the past than what we measure them to be today. Another line of evidence came through our C-14 project, and when we started the project, we were aware of reports in the standard carbon-14 literature of high levels of C-14 in essentially every fossil that had been tested and reported. And this was of concern because it was thought that this C-14 was a result of faulty lab procedures. And so labs all over the world mounted a major campaign to find out what they were doing wrong, how this C-14, which they considered had to be from modern atmospheric contamination, was getting into their samples. And so that resulted in scores of publications in their peer-reviewed literature that basically documented this reality. Well, what we did, we got 10 coal samples from the U.S. Department of Energy Coal Repository, and we basically ran those same tests ourselves. We sent those samples to the best C-14 lab in the world, which at least what we considered the most reliable, most accurate C-14 lab. And this chart gives the results that lab gave back to us. And the right column is the age in C-14 years for these 10 coal samples. And the average age of these coal samples, some of them with uniformitarian ages of 300 million years, some of them around 100 million years, and others from around 30 million years, there was no real difference in regardless of where the coal came from in the geological record. It all was on the order of 50,000 years, radiocarbon years. That level of C-14 is far above the detection threshold. So there was substantial C-14 in all these coal samples, and that merely simply affirmed what was already published in the standard C-14 literature, that there's substantial C-14 in bone, in shells, in coal, petrified wood, every kind of fossil that still has organic carbon in it was giving C-14 levels on this order. So this is a real challenge for the standard time frame. There shouldn't be any C-14 whatever in a sample that is actually more than 100,000 years old, according to all the uniformitarian assumptions. And and that's because C-14 decays so rapidly, a half-life of about 5,700 years. So anyway, this was another line of evidence that there's something profoundly, fundamentally problematic in standard radioisotope dating. The rate finding for why radioisotope dating methods yield vast ages for most of the age rocks, namely because the assumption that nuclear decay rates have been constant throughout Earth history is not true, has not gotten significant traction, sad to say. So certainly most people within our circles, young Earth creationist circles, are aware of the rate results. But outside of our community, this work is barely known. We can debate the reasons why this work hasn't gotten more traction, but the strategic importance of this issue simply cries out for earnest further work. We need to bolster our case, get the results out there, and press the case. And somehow that needs to happen, in my opinion. This issue is just so strategic for our whole everything we're seeking to accomplish. So here, about 4 years ago, Andrew Snelling, myself, and Larry Vardaman decided to try to restart the rate project, and we named this restart effort hour for helium. Let's see, what is it? Helium outgassing of uranium in uranium research, something like that. Anyway, so Andrew Snelling, we collected rock samples. We had from several areas. We sent these samples to a German lab, got them analyzed, found that we finally found a sample that was suitable, had high helium retention, low uranium concentration, so the amount of radiation damage in the crystals was minimal, so that we could get reliable diffusion measurements. But we've not been able to find a lab to actually do the diffusion rate measurements. The lab we were working with in Germany, for various reasons, wasn't willing to do that for us. And we've checked with some labs in the U.S., and they are so aware of our work that they would not touch it either. So we're thinking possibly of building our own lab. Now, this is pretty confidential. One is measurement of the C14 levels in alluvial diamonds. And this is as a follow-on to the fact that during the RATE project, we found high levels of C14 in diamond, especially alluvial diamonds. And I'll explain that in a little bit. Okay, so that would be a good project, and to me, a very strategic project. Another is to look at the correlation between C14 level and uranium concentration in dinosaur bones. That's just ready for us to, and I believe that could yield very important insight, very important confirmation. And then the third is what I described just a moment ago: repeat the measurement of the zircon diffusion rate at low temperature from additional rock locations to bolster confidence in the rate finding. So before I move on, I want to say that in terms of the 4 categories of our conference, I consider the conclusion of accelerated nuclear decay to be close to the Bulwark category. That I don't think there's much controversy. I think that's pretty well established, at least among the people who are familiar with the data, familiar with the work. So here it's a matter of getting the case strong enough that we can really press it in the rest of the Christian world as well as within the secular world. Now this is a table taken from our rate technical report from chapter 8 on C14, and these are the results of the C14 measurements of these 6 diamonds that were all from Namibia in Southwest Africa. And I'll mention here that whereas normally we would subtract away what the lab called its standard background, that has not been done here. This is just the raw numbers that they got. And it ranges from 0.15 to 3.9 percent modern carbon. That's the carbon 14 to the total carbon ratio. And I'll just back up. Well, the coal samples that we just looked at, the average for that was 0.25. I just need to read the last sentence here. By way of comparison, the 10 rate coal samples displayed values between 0.18 and 0.54 percent modern carbon when the standard background correction was removed. So if we're comparing apples with apples here, these numbers that we see here are close, a little lower, but close to what we actually saw in coal. We're seeing these similar numbers in diamonds. Now, diamonds are the hardest substance known. It's essentially impossible to contaminate them from the atmosphere. And before they're processed, of course, they're put through an acid and base rinses to eliminate any kind of surface contamination. And so basically we're seeing similar levels of C14 in these diamonds. And that, for a secular person, would be extremely hard for them to account for how C14 could get into these diamonds, which presumably were formed perhaps as millions, if not 1 to 2 billion years ago, deep inside the Earth. So it's an extreme anomaly that just cries out for explanation. There's some kind of exceptional, unusual explanation for how that C14 could have gotten into those diamonds. So what we need to do, we need somebody that has got some experimental experience and ability in these areas to collect a large number. I'd say, 20, 30, maybe 50 diamonds from around the world, and then get them analyzed at a good lab, and then I'm expecting to see these same kinds of numbers in these diamonds, and then publish it. Have this done very carefully, professionally, and then seek to publish it in the secular literature. All right. Now this is I mentioned dinosaur bone. Over the last 20, 30 years, a number of creationists have taken the initiative to get dinosaur bone tested, analyzed for carbon-14. And one remarkable finding is that the C14 level in dinosaur bone is substantially above the levels that have been found in most other fossil material, several times higher. So in terms of, and so I've got, 24 analyses here. This was published by a group known, they call themselves the Paleochronology Group, a creationist group. I would say many of whom are part of the Creation Research Society. Maybe Gene knows. Do you know anything more about that group? It's something separate from the iDino project, but I think there is some overlap. So anyway, you see the C14 levels expressed in C14 years before present, and typically most of these are between 20 and 35,000 years, which is quite a bit younger than those numbers like for the coal. In terms of percent modern carbon, you see some of these going up to 5% of modern carbon, whereas the average coal was 0.25%. So these dinosaur bones are much higher in C14 than what we were seeing in coal and shells and other things. This is the other 12 that they've published. It's on their website, and at I think the 2013 ICC I spoke. They had a poster there, I think, and I tried to speak with them, saying that for me it would be very strategic to get the uranium concentration measured in the bones, and they just would not even listen to me. They weren't interested at all. I don't remember who it was that I was talking to, but basically the reason why measuring the uranium level is that, as we pointed out in our rate report, it appears that after many of the fossils were deposited, it was accelerated decay of uranium in the environment that transformed nitrogen and carbon-13 in the environment to further carbon-14. So that seems to be especially the case in these dinosaur bones. Dinosaur bones are notorious for concentrating uranium from the groundwater and giving high levels of uranium in the bone. I worked briefly while I was at Los Alamos on the excavation of the Seismosaurus, which was found by a hiker around 1990 in central New Mexico. At that point, it was the longest dinosaur that had ever been discovered, and it was discovered by a hiker who noticed this, what was a tail vertebra from a dinosaur bone sticking out of the ground, and as it was excavated, people got pretty excited because it looked like, first it was a very large dinosaur, looked like all the spinal column was going to be found. It was disappointing that the head was missing and that the four legs were missing. So it didn't turn out to be a spectacular museum specimen, but nevertheless, it did yield some important results. It was the first demonstration that there was preserved protein in the bones. The lab, some of the chemists at Los Alamos checked the bones for protein and identified that the protein was well enough preserved. So that was in 1990, and since then, there's all these examples of soft tissue preservation. But anyway, at one point we were using Geiger counters to try to find where the spinal column was located underground, because these bones were so radioactive, had absorbed so much uranium. Anyway, I believe that if we could maybe get access to some of these bones that they've already got the C14 measurements, if we could remeasure them for uranium and look for the correlation between the uranium level and the C14 level, that would confirm that the C14, these extreme levels of C14, are a result of accelerated nuclear decay from the uranium in the recent past. And in my chapter in the rate book, I show why it requires recent accelerated nuclear decay to accomplish this. So this would be a strong confirmation, which I believe would cause some ripples in the secular community for them to be challenged with these kinds of results. Another couple of guys with ICR, Brian Thomas and Vance Nelson, published additional C14 dates on dinosaurs in 2015, and their results are shown here. They're very similar to what this other group had found, dates ranging from on the order of 20 million to 37 million years thousand years of radiocarbon years. In this case, one of these dinosaurs had 7.46% modern carbon. So it'd be good to especially check the dinosaurs that have high levels of C14 and those that have low levels of C14, and see if we can't establish from a statistical standpoint a strong correlation between the uranium levels and the C14 levels. So, and then in terms of the helium work, again, I showed this figure a little bit earlier, reporting helium retained in zircons, claiming that this retained helium yields ages of tens to hundreds of millions of years for rocks that have been cold at the Earth's surface. So how are those results to be reconciled with our findings? One of the many examples of these published reports in the secular literature is this one from a volcanic tuff deposit in Colorado, the Fish Canyon Tuff, and this is the dots are the helium retention ages they report, whereas the line is the uranium lead age for that tuff. And there's a almost perfect correlation. What that implies is essentially 100% of the helium that's been retained, 100% of the radiogenic helium from the uranium decay has been retained in these zircons. So 100% retention, essentially. So they believe, they're convinced, and they're publishing the view that this method is a reliable way of dating these kinds of rocks. It basically tells how long the rocks have been cool at the Earth's surface below what they call the closure temperature, below which you have no more helium leakage. So they believe this is showing, as you might expect, this volcanic tuff, which is real near to the Earth's surface today, has been cold ever since soon as it cooled after it was erupted, and therefore it's retained all its helium. So this is one example. Another example is from another paper. These are zircons from Sri Lanka, and which the helium retention age matches almost perfectly the radioisotope uranium lead age. So it's not perfect. It's the uranium lead age here is 555 million years. The helium age is 450 million years. Million years. So what difference in assumptions or methods is responsible for this drastic difference in rock age between these papers and the results obtained by the rate team? Well, that difference is straightforward to identify. If you read their papers, these researchers, using the uranium thorium helium method, are applying the helium diffusivity measured at high temperature to evaluate, interpret the helium retention at low temperature. So you can get from their papers that what they're doing is measuring the diffusion rate marked at high temperature, which is indicated by this dashed red line, and then simply assuming that diffusion rate, those diffusion properties apply at all temperatures, and they extrapolate that to low temperatures, and they have basically low diffusion at these low temperatures, very low diffusion. The other plot is our measurements from the rate work, involving in this case the squares are the measured retention values, and the black dots are the diffusion measured values. And so we get a different low temperature trend, a different trend in diffusion rate at low temperatures than what you find than is the trend at high temperatures. So you have a difference in diffusion rate of something like 5 or 6 orders of magnitude. So in our case, the diffusion rate is high. It means the helium has to leak out quickly, whereas in their case, the diffusion rates are very small, and there's essentially no helium diffusion at surface temperatures. Okay, So what we're expecting with further reproducing our diffusion measurements we did in the rate project is that if we do additional step heating helium diffusion analyses, that these will closely reproduce the results of our 2003 rate study. And the reason is, based on publications since then, the uranium thorium levels in our rate zircons are in the range commonly reported in these studies by other people. So we believe the sample that the zircons we measured in our study are representative. They're not outliers. They're not exceptional. They're right in the mainstream of what is normally measured. We already have a set of several thousand zircons separated from a rock body in Minnesota. The helium retention in these crystals has been already verified. These zircons are ready for actual diffusion rate analyses. All we need at this point is a lab willing to perform these measurements for us. Okay. So anyway, this is in some sense a status report of this whole enterprise of trying to overturn this major pillar upholding deep time, namely radioisotope dating. We believe we have identified the reason for it, and that is that at episodes in the Earth past, one we have verified was during the flood itself, and the other has to be during creation week. So it appears that some 90% of all the nuclear decay that we see recorded in rocks occurred during creation. It primarily established through radioisotope measurements. We believe that so we believe that's the reason these methods give these ages from millions to billions of years, while the actual amount of real actual time since creation is only a few thousand years. So anyway, we believe this is extremely urgent, should be a high priority for creation scientists to engage on, for organizations who are interested in defending the authority of the Bible to invest in. And so there's, as Steve pointed out, there's not many of us around to do this. So I'm using this to call for help, call for assistance on this front. Okay, so as far as whether it's a bulwark, I believe that our conclusion that nuclear decay occurred, accelerated nuclear decay occurred, I believe that is based on all these analyses, is a bulwark. But as far as establishing it and giving it enough credibility to get traction, we could use some further research. So that's how I would cast this area as far as Steve's 4 categories is concerned. So now I'm going to shift gears. I'm going to now talk about the Genesis flood, and our ability as creationists to account for the Earth's Phanerozoic rock record in terms of this year-long cataclysm. So this enterprise has many facets. So I'm going to cover several here, hopefully in the next whatever more time I have. Not much time. I've got another talk tomorrow. All right, so let me launch into this. How well does our understanding of the flood account for the Earth's Phanerozoic tectonics features and history? So I'm going to focus first of all on the tectonic aspects of the Earth. Well, a huge discovery of the 1960s was culminated in this new understanding of the Earth called plate tectonics. This new paradigm, many people referred to it as being that. And that involved the discovery that the continents are mobile, that they had not been at their present locations since early in Earth history, as had been believed more or less by the majority of the community up until 1960. Further, new ocean floor is formed as two continents move apart. As these mobile continents move, as two of them move apart, that new ocean floor is formed between them. And then another aspect of this framework is that older ocean floor plunges into the mantle at deep ocean trenches. Another thing that was discovered, a major thing that was discovered, is that all of today's ocean floor, all of it, has formed since the Paleozoic rock record was formed on the continents. So that all of today's ocean floor is recent in Earth history. So let's look at where that point falls within this sediment record, this fossil-bearing sediment record. This blue arrow marks that location. It's basically very close to the boundary between what are called Mesozoic rocks and earlier Paleozoic rocks. It's roughly at the Paleozoic-Mesozoic boundary. It's basically at the top of the Kaibab limestone, which is at the rim of the Grand Canyon. If you're there at the rim of the Grand Canyon, you're standing at that boundary, on that boundary between the Paleozoic and the Mesozoic. So you see that even though there's almost a mile of layered fossil-bearing sediment layers below that boundary in the Grand Canyon, you've got 2 to 3 times the depth of rock above it in that part of the western U.S. So it's anyway. This is to make the point. The point I'm going to make here is that all of today's ocean floor had to form since the beginning of the flood, and according to the Bible, that had to be less than 5,000 years ago. And so all this implies that the opening of the entire Atlantic Ocean occurred during the flood, and also that the continents migrated by thousands of miles in only a few months' time. So all of these conclusions, I would say, is in the category of a bulwark. It's simply those observations I've just surveyed that form the basis of this concept of catastrophic plate tectonics. It comes down basically to the age of the present ocean floor, and that it's young relative to the fossil-bearing sediment record on the continents. If we understand fossils being a reliable indicator of flood activity, of the flood, then that means that a lot of seafloor spreading had to occur during the flood. The argument is just that simple and just that logically tight. So I believe the reality of catastrophic plate tectonics is a bulwark for us. I know that there's still people holding out and not wanting to accept that, but in my view, they just haven't been exposed to the information that leads to that conclusion. But the question that then demands an explanation is, how can such large-scale plate motion unfold in such a brief span of time? How can you have the opening of the Atlantic, 3,000 miles wide? How can that happen in just a few months' time? What conceivable process would allow that to occur? Well, the answer had already been provided through experiments that had been undertaken during previous decades in mineral physics labs in many places around the world. So even before I presented this evidence for catastrophic plate tectonics at the first international conference on creationism in 1986 in Pittsburgh, even before that, the answer for how it could happen was already in the mineral physics literature. This is an example of an apparatus in many of these mineral physics labs dating back from the 50s, 60s, let's just say certainly the 1960s. This particular lab is in Paris, where this photo was taken. The cylindrical feature there in the middle is an oven for carefully controlling the temperature of the sample, which is in the middle of that cylinder. And then force is applied to the sample through these alumina rods that penetrate into the oven. So the amount of force can be controlled and measured, monitored very, very carefully, and so you can put the sample at a given temperature, apply a certain amount of force to it, and look how fast, how rapidly it compresses. And then once the sample is deformed, you can take it out, examine it under an electron microscope, and actually see the physical evidence of deformation at the surface of the crystal. And this top image shows these parallel lines. Basically, those represent planes of atoms that have slid over one another as that crystal was subjected to shear stress. And that crystal deformed like a deck of playing cards. If you shear them, there's slip on in between the individual cards, and you get on the edge. You'll see a pattern as that deck is sheared, like you see in that photograph. So these kinds of studies had been conducted at least 20 years, 25 years before I started talking about catastrophic plate tectonics. And these measurements were well known, well published, so that in this review paper from 1983, there is this figure showing, giving a map for how this mineral olivine deforms under various amounts of shear stress and at various temperatures. So the temperature is shown on the top of the figure in degrees centigrade, and the vertical axes show the amount of shear stress. The actual amount is on the right hand side, and then the individual lines on the plot represent lines of constant strain rate or deformation rate, or how much the crystal deforms per second when that kind of stress is applied to it. So I know this is very complicated for most of you, but all I want to say is that one point I want to make: at 80% of the melting temperature on the bottom of the graph, it's temperature normalized or divided by the melting temperature. At 80% of the melting temperature, which is roughly the temperature of most of the mantle, you can go vertically along that point and see that the rate of deformation can change by a factor of more than 1 billion for relatively modest changes in the shear stress. Now, the actual measurements in the lab are shown are these curves where it says laboratory strain rates. Let me get my pointer here. I keep pointing to my computer. That doesn't help you. All right. So here the shear stress, temperature, normalized of the 80% of the melting temperature. This is this is like 1/1000th. This is a normalized shear stress, normalized to the what's called the shear modulus, elastic shear modulus, 1/1000th of that level. These curves right here are curves that were actually measured in the laboratory strain rates. And the deformation rates needed during catastrophic plate tectonics are right in the range that had been measured in many laboratories by this time for this mineral olivine. Deformation rates during the catastrophic plate tectonics are on the order of 10 to the minus 5 per second and 10 to the minus 4 per second. So this is the 10 to the minus 4, this is 10 to the minus 5. So right here in this range this is what we need for catastrophic plate tectonics to happen, and it's right in the range that has already been established, measured, remeasured, reported, peer-reviewed, and in that literature. So what I did once I got the numerical ability to calculate such catastrophic behavior, I encoded this. I encoded this deformation law, put it into a computer program, and solved the equations for conservation of mass, conservation of energy, and a force balance on every cell using what's known as the finite element method in a box with a height of which was the thickness of the mantle, but had a cold layer on top, a hot layer on the bottom. And basically I found that this runaway, I found that runaway immediately takes place. This have a cold blob starting up here at the top, hot material at the bottom, and already after 2 days we have a sinking velocity, maximum velocity of 4 meters per second, and at 5 days that blob is halfway down to the bottom, and after 15 days it's hit the bottom, and then that's after 40 days it's spreading out over the bottom of the box, and the hot material is rising and helping push the rest of the cold material to fall down to the bottom. The energy driving this process is simply the what's called gravitational potential energy associated with these initial temperature differences. I forgot to mention that blue refers to cold and red's hot, and the temperature range, this is the overall temperature range between red and blue. And so this, basically the physics works. The physics of this process works. It shows that if you have cold material at the top and or hot material at the bottom, it's gravitationally unstable, and the material wants to move toward the opposite boundary. And because of this, the fact that these minerals weaken with increasing stress, it leads to a runaway. That opens the possibility of a runaway instability, and that arises in these calculations, and you get this kind of behavior. Now, we've made quite a bit of progress since 2007 when I did this particular calculation. All I want to emphasize here that the physics is straightforward. It works. It's non-controversial, and again, I would say it's probably at least the status of this is at least in this second Steve's second category, if not a bulwark. It's a bulwark for anybody that has the ability to understand what I'm doing. I think there's no real controversy if you have enough physics background to understand what's going on here. Now, considerable progress has been made over the past 12 years in understanding the stress weakening mechanism in silicates. I give God the glory that we now have the state-of-the-art silicate deformation model in our numerical codes. There's a guy that just finished his PhD at Mississippi State University in the mechanical engineering department. Actually, his degree was in computational engineering. But basically what he did was take this a state-of-the-art material model for metals. It has been very successful in predicting metal failure, metal behavior, metal deformation in a wide range of engineering applications, especially in the automotive industry. Taken those methods, applied it to silicate rocks, and made a major advance in understanding how silicates behave. This work was of such interest that he got invited to be a visiting fellow at Yale under the top mineral physicist in the world. So that's where he is right now. So he's a dedicated young Earth creationist with that kind of opportunity. So I'm excited. I'm basically hoping I can hand off the work I've been doing all these decades, hand it off to him. A very gifted guy. His name is Heechin Cho. He's Korean. Heechin means heavenly joy. And so he's a strong believer, dedicated creationist. I've already seen him tested a little bit under fire from the atheists, and he stands his ground. So not that I don't need to continue to earnestly pray for him, but I'm excited that God's raised up someone like this young man. Okay. So what about some of you that have been tracking this work on catastrophic plate tectonics is aware that I've for a long time been looking at how this works in 3D. And so this is the grid for my PhD at UCLA to work on this issue of the flood. The Lord allowed me to develop a 3D model for the Earth's interior. This is for flow in the Earth's interior, and this is the grid that working with a mathematician at Los Alamos National Laboratory, I applied to that problem. And this particular grid has 1.35 million cells, chops the metal up into that many small chunks, solves the conservation equations, force balance on each little chunk, and is able to solve for flow inside the Earth, just like that previous little animation. So I'm going to show an example case. It begins roughly midway through the cataclysm. So I'm not, in this case, trying to model the entire flood, just roughly the last half of the flood, starting from Pangea, which is illustrated here, one reconstruction of Pangea. This is my own reconstruction of it in the code, what I used for Pangea in the code, and to get the calculation going, if I don't have some cold material someplace, nothing will happen. So I put some cold material that's 400 degrees colder than the surroundings, and also goes down 400 kilometers down to the Earth, basically surrounding much of this supercontinent, plus a little piece that comes down toward Australia in this configuration. This is a cross section at that initial condition, showing this colder material going down just 400 kilometers. It'd be nice if I had some way to know what the actual temperature distribution was. That would be ideal to start this calculation. But not knowing that, I simply have found that this kind of initial condition will basically cause that supercontinent to break up as the observational data indicates that it did break up. So this is a animation showing that. So this is a slice through the equator showing that cold material diving down and starting to cover that lower boundary. So, I'm sorry. This is looking at the surface as this process unfolds. It shows that the material sinking around the margin results in motions that pull this supercontinent apart, and that basically the blocks move roughly in the right directions. It's not perfect, but it gives you a flavor for how this really does can reproduce something like what actually occurred. This is a view from the North Pole, showing that motion. Another view from the South Pole. So I've spent considerable effort trying to model this in 3D, but the reality of catastrophic plate tectonics does not depend on these computer models. That's established from that observation of the age of the seafloor. Okay. So do we have any observational evidence that supports this version of plate tectonics, this catastrophic recent version of plate tectonics? Well, yes. Over the past 30 years, the field known as seismic tomography has provided spectacular evidence for a recent episode of catastrophic plate tectonics. And these are, I'm going to show some seismic images of the mantle, showing a ring of surprisingly cold rock, at least from the secular perspective, at the bottom of the mantle beneath the subduction zones that surround the Pacific Ocean. And this is the seismic tomography. The blue represents cold material at the bottom of the mantle, and then and you can see this one ring from both the view of the Western Hemisphere and the Eastern Hemisphere. Here's Africa in the Eastern Hemisphere. Here is Japan. Here's North America, South America. And you see this ring of cold material basically beneath the subduction zones around the Pacific. But you also can see it inside the Earth from this perspective. These red blobs appear to be hot material that was squeezed up as a result of this cold material sinking down to the bottom. Hot material squeezed up like toothpaste in the middle of the ring. There's one blob in the Eastern Hemisphere underneath Africa, another blob under the Central Pacific in the Western Hemisphere. So the problem of why this is so important or so noteworthy is that the inferred, looking at the seismic velocities through these different regions, indicates a big temperature difference in them. Difference estimated to be at least 3,000 degrees centigrade. Well, that's almost the difference between the surface rocks today and the material near the core mantle boundary. So that means that the rock in this cold ring is very close to the temperature of the lithospheric plates at the surface today. And because even though rock is an insulator, doesn't heat up very rapidly, compared with the evolutionist time frame of roughly 100 million years for a slab to get down to the bottom. If it had been sinking for 100 million years, you wouldn't see any strong contrast like this. This strong contrast means that the rock has gotten down there extremely recently. And in my view, a powerful evidence for a recent episode of catastrophic plate tectonics. So the secular world, this is a real problem for them, and they have struggled over the last 20 years, especially in trying to come up with an explanation for this feature, and trying to argue, well, somehow it's a chemically material that's chemically different, and therefore it has different seismic velocities. But none of these explanations really themselves acknowledge that. Okay, I think I've exhausted my time, and so I would say this probably is in category 2, this evidence, but it's to me pretty strong evidence for a recent episode of catastrophic plate tectonics. So I'll hopefully maybe tomorrow I'll talk about the tectonics during the first half of the flood, and then in my second talk I'm going to talk about erosion, sediment transport, and deposition during the flood. And in other words, I'm going to seek to explain in terms of I'm trying to give an explanation of how such a sediment record, a layer cake style of sedimentation that blankets all the continents today, how that was produced in a very short period of time, a few months' time during the flood. And I have a numerical model which is looking very positive at explaining that. But this is a huge requires this is no small task in accounting for that record. And what I'm going to show you is my first effort, my first attempt at explaining it. And I'm excited that my model is giving a pretty good correlation as far as where the thick deposits of sediment are on the continents today and where there is no sediment deposition on the continents. It does a good job at approximating that. So that's extremely encouraging. So at this point, I think I better have some questions, Q&A.
John, at one of our conversations today, you surprised me, educated me, when I learned that the mantle of the Earth is not liquid. In fact, you said it's at that pressure, it's about 80% of the melt temperature. And common ideas, we see volcanoes, we see rift areas, we see lava coming up, so most people assume that the mantle is liquid. Well, you have videos we just saw of rock sinking through solid rock. That doesn't happen to solid objects. Can you please explain to me, the audience, how you can move things through, how a solid thing can circulate?
Okay, excellent question. This was something that one of the most highly respected geophysicists did not understand through much of the 20th century. And he held back this concept of plate tectonics almost single-handedly, because he insisted that the seismic measurements, the seismic velocities we measure for the mantle, show that it's has elastic properties near that of high-grade steel, and there was no way that continents could plow through something that strong. Okay, what he did not understand was what is called solid-state creep. Solids do deform under stress, undergo permanent deformation under stress. And the way that works is that especially especially happens at higher temperatures. In a solid,
hence the World Trade Center, the steel doesn't have to melt.
No.
It just has to get hot, and then under that stress, it'll bend and flex, and the whole thing comes down.
Right.
Okay.
But I'll give you a little bit more detail there. In every solid, there are defects in the solid lattice. There can be missing atoms, for example, or extra atoms in certain locations, and there are what are called dislocation type defects as well, where just the pattern of atoms is not regular. There's maybe an extra row of atoms. So when that kind of solid is put under stress, those defects can migrate to reduce some of the local energies, and and that when those defects migrate, that leads to permanent deformation. And so that's the way. If you bend a steel rod, for example, up to a certain point, it will just deform elastically. If you take the stress away, it will return to its original shape. But if you bend it strongly enough, it will retain its deformation. And the way that works is this process of migration of defects. Okay, and that's a well-known aspect of the way materials behave. And so it's in terms of a worm, in terms of the mantle, that process is often referred to as solid state creep. And under many conditions, you can treat that deformation of that type of material simply as a what's called a Newtonian fluid, or just a regular type of fluid, and with a viscosity. And so
at these scales,
at these large spatial scales,
this much pressure, this much distance,
yes,
it looks like it's flowing, but it's really just like steel bending.
Yes.
So if you went and zoomed up on one little part, it wouldn't be like this part is bending in half. But
no.
on a scale of 300 or 400 miles, you can get something.
Yeah, you don't need much local deformation if the scale is hundreds of miles to get significant overall deformation.
Awesome, thank you.
That's important. It's important for people, in order to be able to accept this and believe it. They need a little bit of that understanding. So thanks a lot for that question. Yes, Mark.
I had a question about uranium and the dinosaur. I had a question about the uranium and the dinosaur bones. By what mechanism does the rapid decay of uranium? You're talking to alpha decay and beta decay.
Alpha. That's a good question. Excellent question. It's a multi-step process. Uranium, when it decays, produces alpha particles. It's been discovered that alpha particles can interact with medium atomic weight elements like oxygen, silicon, calcium, aluminum, potassium, and produce neutrons. There's a reasonable cross-section for an alpha particle interacting with one of those kinds of atoms and producing neutrons. Those neutrons, in turn, can interact either with a nitrogen atom, like occurs in the atmosphere, to produce a C14 atom. So you get C14 from nitrogen 14 plus a neutron. Or it also, you can produce carbon 14 from carbon 13, neutron interacting with carbon 13. And so in the environment, if you have nitrogen, and certainly near the surface, there's, if you've got air, well, you've got protein that has lots of nitrogen. You've got, soil tends to have nitrogen in it. Atmosphere has nitrogen. So there's nitrogen around near the surface. And then there's carbon 13 if there's any organic material. About 1% of carbon is carbon 13. So neutrons react to with both of those isotopes to produce carbon 14. So if you've got a dinosaur bone that has absorbed a lot of uranium from the water that's in the groundwater, from the groundwater, then you're going to tend to get a lot of neutrons and a lot of C14 production. So, that's only that I'm talking about. You get substantial neutrons only enough to produce enough C14 to hang around long enough for it to be detected, only if there's accelerated nuclear decay. So the finding of a correlation between uranium and carbon 14 is an argument for recent accelerated nuclear decay. I didn't have time to really explain that, but yeah, that's a good question.
I understood your explanation, and I'm wondering if maybe the resistance this one group gave you to investigating uranium. A lot of times when I bring up the carbon-14 argument with secular people, the go-to answer sometimes, go-to answer is contamination. But the second answer is, well, it was generated in situ by neutrons from spontaneous carbon fission or something like that, or spontaneous uranium fission, and those neutrons being absorbed and creating the carbon-14. So I'm wondering if maybe the strong reaction you got was that seems to be helping the secular case.
But I showed in my chapter, in my rate chapter, that at current uranium decay rates, the rate of that type of C14 production is so tiny that you will never detect C14 from that source. In order for you to detect some C14 by that mechanism requires very rapid uranium decay. So I'm saying the reason this is important is that it will validate this proposition of very, very rapid uranium decay in the recent past. Yeah.
Yes, that would also, I didn't know this, but that would also distinguish between the different mechanisms I was talking about, because if it changed over to beta decay as a result of the change in mass of the Neptunium-238 or the U-238, then there wouldn't be alpha particles directly from the uranium. And so you would not get the result you were thinking of if that occurred. You might not get that result. It might be further down the decay chain. You'd have alpha decays. But
yeah, there was one that raises an issue that came to my mind is that first uranium alpha decay is just 1 of 8 before you get down to lead-206. So you've got 7 more alpha decays that you've got to deal with.
if you follow that decay, it goes back to the regular path after a couple of decays. You might still have that. I guess you'd have to run the numbers to see if you still get enough carbon-14 produced from the accelerated decay of the uranium if it's by that mechanism.
So what you're talking about is a correlation between two clocks, between the carbon-14 clock in dinosaur bone and the uranium decay clock, right? And that reminded me of the radio halos with polonium. That the polonium the uranium has to be produced very quickly in order to get the polonium, and so it's another kind of a correlation showing that the decay of uranium has to be very rapid in order to support carbon-14 decay or the polonium decay.
Exactly.
Am I right about that?
Exactly. No, that's exactly right. It's this very same type of argument.
Huh. That's really good.
Yeah, I didn't have time in my brief summary to talk about the polonium halo line of evidence for recent rapid nuclear decay.
I thought that was, in terms of the Ray project, I thought that the diamonds and the polonium were the most amazing because you cannot get polonium, because of this very short half-life of polonium, you cannot get these radio halos unless you have a constant resupply of uranium. And that'd be really fast decay. Anybody else have any questions? No other questions? Really? Go ahead.
So I thought you said your runaway mechanism could start either by a cold, upper layer starting it, or see not only cold blobs, but very hot blobs down there in the mantle. Have you investigated much? Maybe something happened that caused a huge heat event that actually started it rather than a cold event?
At least over probably the last 20 years, I typically have a hot layer at the bottom and a cold layer at the top. But you're right, either one will get it. Well, by adjusting the temperatures, I can choose which one goes unstable first. Once one of the layers goes unstable, it almost immediately triggers the other to go unstable. But I can if I make the bottom layer hot enough, it will be the one that runs away first. So yes, it could be either one.
You know, they say when you got a hammer, everything looks like a nail. So my degree's in nuclear engineering. So I see nuclear reactors everywhere. The Oklo natural nuclear reactor is a mysterious event because it really shouldn't be there. Well, especially from a young Earth perspective. So I'm wondering if there couldn't be something that triggered like a huge fission. I'm not talking fusion, but a fission reaction event deep in the Earth. Could have started the catastrophic plate tectonics. Could have created many neutrons to do all other kinds of nucleosynthesis. But when you got a hammer, everything looks like a nail.
Yeah. Well, it's probably one of the most common questions I get when I talk about catastrophic plate tectonics is what triggered it, what got it started, and that's I commonly say I do not know. I mean, I do not. There's some various possibilities, including one possibility is that the Earth could have been created, at the end of creation week with some, hot material at the bottom, cold material at the top, and then it just took a little time for it to move a little closer to instability before it really broke loose, and that perhaps something that happened at the fall, God might have just said, "Okay, I'm going to let things go," and it just so happened that when the door of the ark slammed shut, this instability cut loose. But I don't really. So I did publish a paper. I think it was in 2003 with Mark Horstmeyer, where we allowed for that possibility that there might not need to be any trigger as such at all for catastrophic plate tectonics. But as far as actually what answer do I have, I really don't know. I don't know what might have initiated it. There's a question up there.
Well, I'm just learning. So when you're talking about the flood and the fountains of the deep bursting, could that have started a change in the tectonic plate and the temperature levels, and I don't know if it's a reversal from hot to cold to hot, making those substantial changes that release decay at different.
Well, there's several issues you're raising about. One is we're discussing it at lunch. What were the fountains of the great deep? What does that term refer to? I don't know if I want to. I'm not sure. You weren't asking that specifically. Just to try to give a quicker deeper answer. I believe that the breaking up or pulling apart of the fountains of the great deep was a consequence of things going on inside the earth. That this runaway process was already triggered. It wasn't the breakup of the fountains of the great deep that triggered the cataclysm. That the cataclysm was already beginning to unfold, and one of the consequences of that was the breaking up of the fountains of the great deep. I will comment about what the fountains of the great deep may have been. I pointed out at lunch that on the earth today, we have what could, I think, accurately be termed fountains of the great deep. There are great, what are called black smokers along the mid-ocean ridge system. Because of the hot rock beneath the mid-ocean ridges, seawater is circulated. Cold water filters down through the cracks in the seafloor, encounters this hot rock, and then is heated and then rises and expelled in these jets, in these vents that are along the mid-ocean ridge systems. Typically, they have acquired some black sulfate minerals, so that there's that looks like black smoke coming out of these chimneys. So these are like fountains on the ocean bottom today, and you know, if the ocean is the great deep, we've got fountains of the great deep on the earth today. And it's my suspicion that the earth had similar features on the sea bottom before the flood. So it could well be that that Hebrew word for well, various translations translate it differently, but the breaking up of the fountains of the great deep may well have been just the disruption, the pulling apart of those pre-flood fountains. But that unleashed even greater fountains as this rapid plate tectonics caused a lot of molten rock to be right up near the surface on the sea bottom. And that hot rock would heat the water to what's called supercritical water, which then essentially exploded into supersonic steam jets that came racing up through the oceans, and produced a chain of these geysers, some 40,000 miles long around the earth, bringing up and training lots of liquid seawater, and having that water would fall immediately as heavy rain. And so that to me would also qualify as a fountain. So just exactly what is intended in the text there in Genesis 7, fountains of the great deep. My best guess would be that it's similar to the fountains that exist on the earth today along the mid-ocean ridge system. But I believe that was a consequence of this instability that was kicking in inside the earth. I don't know if whether that satisfies your question.
Yes, with the age, rate of decay issues, how would the chemicals and the catastrophe and the things that you describe, would those have any effect on any of that rate of decay or the chemicals released?
Okay. Well, during our rate work, we concluded that about on the order of 600 million years worth of nuclear decay at today's rates unfolded very quickly during that year of the flood, and the amount of heat that was produced was if you look at the crustal rocks and the amount of radioactivity that they contain, that would be enough heat to melt or even vaporize the entire crust of the Earth. So there had to be some mechanism that removed that heat almost instantly, and that was one of the issues we faced in the rate project. And just a simple conclusion was that perhaps the increase in nuclear decay rate, the opposite side of the coin, somehow removed the heat. There was some kind of an accompanying process that allowed that heat to be removed. And I'm convinced 2 Peter 3 argues for God's intervention during the flood, supernatural intervention in the laws of nature. And so, although as a scientist I'm extremely cautious and resistant to invoking a miracle, I believe in trying to understand the flood that there are a couple of points where I basically run up against a brick wall. There's no way that I can understand having the laws of nature that we understand today account for what seems to have occurred. So one is the rapid nuclear decay. Perhaps Gene will succeed in finding something that doesn't seem to require any miraculous intervention. On the other hand, he may not. And I'm not aware of any mechanism that can get rid of that much heat in a short period of time. So I'm not so optimistic about finding any non-supernatural explanation for the heat removal of that heat. And that, whether you want to call that a frontier, it's certainly something I can't give a confident answer to, other than I'm fairly confident we can't explain it by natural means.
Maybe one more question, and if not, well, actually, I think we're going to have to stop. So the next thing is Dr. Baumgartner is going to read the list of Art Chadwick. Do you have the list?
No.
Oh, you don't have the list. Okay, I have the list on my computer. What? You could email it to him, or you can just use my computer. Okay. I'll do that. It'll take me a few minutes. Okay.
For some reason, I can't connect to the Calvary network. It quit working last night, and I've not since been able to do it. I can try it again.
Do you have a flash drive?
Yeah.
We'll just put it on a flash drive for you, okay? Yeah, let's take a break for about 10 minutes.